Let's use round numbers here and say 300,000 kilometers per second to represent the speed of light, which is 299,792,458 meters per second, or 299,792 kilometers per second. The speed of light is also the highest speed that can be achieved in the universe, or is actually not possible because it requires no mass or constituent parts, which means that it is impossible for physical life to exist at that speed. Nonetheless, we can travel very near to the speed of light. Even though light speed may seem fast, when you consider the distances between stars, it is not all that spectacular and falls short of our aspirations as humans to travel quickly between stars. Even if you are talking to someone who is 1 meter away from you, you would see him 3.3 nanoseconds ago, or almost a billionth of a second in the previous 0.000000003 seconds, because light has a limit on how many times it can go around the Earth in a second. You can never see everything in the cosmos as it is right now. You can only view everything as it was in the past. Everything you see around you is how it was, not how it is right now. Let's begin with recognizable objects like the Moon, which is 380,000 kilometers away on average and appears 1.3 seconds in the past from Earth. Our Sun is currently 8 minutes away as seen from here. Moreover, Mars is often 14 minutes in the past. The fact that light speed is the maximum speed for all speeds including radio waves, microwaves, gamma rays, and all other waves, means that the rovers that humans sent there take an average of 14 minutes to respond to a single command from Earth. It also means that you will never be able to see Mars in real time. Let's go on to a different star and a different system. Alpha Centauri, the nearest star system, is 4.3 light-years away and contains 3 stars. Proxima Centauri, the nearest star system, is 4.2 light-years away from our Sun, which means it would take light 4 years to travel there. Let's say there is an alien observer in Proxima Centauri right now. If they had a telescope large enough to observe Earth perfectly, the mirror would likely have to be several thousand kilometers in diameter. The alien observer would see Earth for years in the past, and from space, the Earth would appear to be relatively unchanged. However, if it were an extremely large telescope, let's say 25 millimeters in diameter, the center of our galaxy, the Milky Way, is 25,000 light-years away, so when we watch it, we see it 25,000 years in the past. This also means that when we observe Alpha Centauri stars, we see them 4 years in the past, and the same is true of every other star. Let's take it a step further with planets. Assuming that a star 2,000 light-years away has a solid planet, an alien would need a telescope with a diameter of at least hundreds of thousands of kilometers in order to observe Earth from that star. If they came from a planet 2,000 light-years away, however, they would see Earth at night rather than with the bright cities we see on Earth today because there were no street lights or other artificial lighting sources. And if they could pinpoint every human, they would first need a telescope that was 11,900,000,000 kilometers across, about the size of our solar system. With such a massive telescope, alien observers from such a great distance could see the Romans and other ancient civilizations, and they might even catch a glimpse of a war that was taking place 2,000 years ago, but humans would certainly appear to be very different from that point of view. Let's go on and talk about another galaxy. Andromeda is the nearest large galaxy to our own and is larger than the Milky Way. It will eventually collide with our galaxy. Andromeda is 2.5 million years in the past since it is 2.5 million light-years away. Hence, a telescope with a diameter of 15 trillion kilometers, or nearly 1/4 the distance from the Sun to Alpha Centauri, would be required if an extraterrestrial observer from Andromeda desired to watch Earth and the species of its era. 15 trillion kilometers is larger than a light year. Since it is 1.6 light years long, it will take 1.6 years for light to travel from one side of the telescope to the other. It's unclear how such a telescope would work. Although the planet wouldn't have changed much and there wouldn't be any modern humans, it would be interesting to observe the Earth 2 million years in the past. Observers in Andromeda would see Australopithecus, or ancient human descendants, with their stone tools and way of life from this time on Earth, but it would not appear to be a highly developed civilization. The Milky Way would be visible to these observers from a distance, which is important to note because from where we are in the Milky Way, we can only guess at what our galaxy will appear to extraterrestrials. The largest spiral galaxy known is NGC 6872, which is 500,000 light-years across, or almost 5 times the length of the Milky Way. Let's venture even further into space. Again, assuming an alien spectator points a telescope that can see even animals from Earth, the galaxy is 212 million light-years away. Hence, this telescope would need to be 1,251,000,000 kilometers big, or 132 light-years broad, since light travels 132 years from one side of the mirror to the other. A particularly large star cluster like Messier 68 is 100 light-years across, which is smaller than this fictitious extraterrestrial telescope. Given that Pangaea existed 200 million years ago and that the galaxy is more than 200 million light-years away, it sees Earth but only one continent rather than the current 7. But they could also see a blue ball, leading them to believe it was an aquatic planet. Yet, alien viewers would first encounter dinosaurs and many other extinct species while staring at Pangaea, including old deserts and mountains. Who knows what information they would learn about the Earth that we do not know? We can therefore go back even deeper in time, but there is now no point because the alien viewer will see Earth further into the past the further it is from Earth. To put these light-year distances into perspective, let's look at the Voyager 1 spacecraft, which is currently en route to the Proxima Centauri star, which is the nearest star to the Sun, but would need to travel 40,000 light-years to get there. Voyager 1 is also moving at a speed of 17 kilometers per second, or 60,000 kilometers per hour, which is more than 45 times faster than a shot bullet. Cosmic distances are, however, far greater than they may first appear, but we should always strive to increase the speed of our spacecraft so that we can explore and learn more. Alright everyone, this video ends here. How do you feel what our planet looks from the Andromeda galaxy? Let us know your opinion in the comments section.